Hey guys, welcome back to series where we are discussing network security. That is for TY BSc-IT semester 5. My name is Professor Tiruk Parmar. Let's continue our discussion. So in last lecture, we are already done discussing many of the points. If you remember, in last lecture, we are already done discussing Polygram Cipher. In this lecture, we'll continue our discussion with Polyalphabetic Cipher. So, what is Polyalphabetic Cipher? Something written here. Now, main definition is not that important. We just need to remember what we mean by this particular concepts and what are the main sub-algorithms related to with this particular type. So, Polyalphabetic is substitution cipher. Remember, we have to highlight this particular point. It's a substitution. Poly means many. It is derived from the Greek word. Remember, this type of algorithm or this type of technique mainly used by Greek people in ancient times. So in the year, like as you can see, 1568, that is in a 15th century, they were using this type of algorithm for many different reasons. So from that time only, this particular type of algorithms got popularity. And now we are using this type of technique in our computer world as well for encryption or for encrypting and decrypting different documents which we send and receive over our network, that is over a LAN, over a WAN, that is wide area network, or over a MAN, that is metropolitan area network. So whenever we are sending or receiving whenever we are sending or receiving document between one or more computers, that time we use some type of a security pattern or encryption technique, and one of the main, or we can say one of the more secure technique which we use, that is polyalphabetic cipher. Now polyalphabetic cipher again gets divided in multiple types. As you can see here, we have polyalphabetic cipher types and it is divided in 4 types, that is Vigenère Cipher, Beaufort Cipher, Time Pad Cipher, and last is Playfair Cipher. So we are going to discuss each and every type in detail. And one more thing, whenever we discuss about algorithms or whenever we talk about algorithms, so when we write this particular type of question in exam, that time we have to write some theory or some basic points about this type of algorithm, and most important part is we have to explain we have to write example in short for each and every algorithm. That is the standard way of writing, and that is the only way how you can score more with respect to your network security paper. So let's start discussing Vigenère Cipher, or in short, as you can see, using a code will. What is a code will here? As you can see, outer will we have our plain text message, you can say, and inner will, that is our cipher text. So what we are going to do, we are going to just spin one of the will, that is, suppose I have spinned inner will, and then as soon as this inner will stops, as you can see, front of A, X appears. So what we are going to do, if A we have in our plain text message, then we are going to replace it with X. So suppose our message is test. So let's see T. So in our message we have, in our plain text message we have T, so that we are going to replace with Q, because Q is front of T. Then E, so E is we are going to replace with B. Same way S, so as you can see here, S we are going to replace with P, and again T, which we are going to replace with Q. I hope this particular technique is clear. It is very simple. So here the same thing is given here. A tool that was used for Vigenère Cipher was a code will. The outer ring of a will represents plain text letters and inner will represents cipher text letters. So encryption method, go to plain text letter in an outer will and find its corresponding cipher text letter. The same we did. I hope this particular technique is clear. It is very simple. Now remember, as algorithm is simple, it is very easy to encrypt as well as for decrypt, and it is very easy to crack that particular algorithm as well. So if any person aware about this particular type of algorithm, then he can easily crack your message, and hence the reason we don't use such type of algorithm when we are sending or when we are exchanging some documents or messages at professional level. So what we are going to do, we are going to use advanced version of the same algorithm. Remember, this is the very basic pattern or basic level of algorithm that is named as Vigenère Cipher. So we are going to use, or we are going to look at the advanced version of the same. So what is the advanced version? Let's suppose this is an example. So I'll just explain you what is this all example all about. Then you can easily refer this particular type of example. So let's just see. Here we have a plain text written here. As you can see, this is our message. This is our message which we want to encrypt. And after encrypting, we are going to exchange this particular message. So suppose our message is on a plane. The plane is due. Or you can choose any other message as well. You can write hello world like we used to do in programming or something. Then we need to choose one key. You can choose, you can write, or you can choose key like your name as well, your surname as well, your pet's name, or anything else. Or it is not always compulsory that it should be some standard English dictionary word only. No, we can use, I can write it ABCD as well. That might be my key. So this is my key. This is my plain text message, and with the help of this two things, I'm going to generate my cipher text. Remember? So let's see how we basically going to generate it. These are the few basic patterns, some of the steps which we are going to follow here. So instead of reading the steps, let's just look at them in a practical manner. So what we are going to do, as we know, we have 26 alphabets. In total, we have 26 alphabets, as you can see here. So we are going to generate a table for the same. So in a tabular format, we are going to write A to Z, and then what we need to do, we need to assign numbers to this particular alphabets. So let's start assigning number like from 0. So for A, we are going to assign 0, then 1, for B, 2 for C. The same way we need to assign all the numbers till Z. So the last number which we are going to assign to Z is 25. So from 0 to 25, total 26 characters. Now this table's reference we are going to take to generate pen coding. Now what we mean by pen coding and ken coding, that's we are going to discuss here. So this is our message which we are going to write here on a plane. The plane is due. This is our message. So what we are going to do here, we are going to replace alphabet which is present in our message with a number which we have assigned in this particular table. So as you can see, we have O in our message. So with O, we have a number linked with, that is 14. With N, we have number linked is 13. With A, we have number linked is 0. Then same way, we are going to replace each and every alphabet in our plain text with some another number. I hope this particular technique is clear. So when we replace alphabet which is present in our plain text with a number, that is called as pen coding. Remember, replacing alphabet in our plain text with some number, that is what we mean by pen coding. Now what we mean by ken coding? Ken coding means we have some key, and when we replace alphabet which is present in our key with a number with reference to this table, that is what we mean by ken coding. As you can see, our key is of 4 characters only, that is MILK, milk, and our message is very long as compared to our key. So what we are going to do, we are going to repeat our key till our message, plain text message ends. So as you can see, MILK, again MILK, write it till the last character. So in last character, we only left with E. So that time we are going to write only one alphabet out of our key, that is M only, first alphabet. Then we are going to replace M with some number which is linked here, or we have assigned in our main table. As you can see, M, number assigned to M is 12. So we are going to write 12 for M. Then for I, we are going to write A. For L, we are going to write 11. For K, we have assigned number 10. So we are going to replace K with 10. I hope this particular point is clear. Now, as you can see here, we have written something here, that is pen coding plus ken coding. Now, what we are going to do to generate a cipher text, we need to add number which we have created, or which we have which we got basically during pen coding. That number we are going to add with ken coding number, and if the addition of this particular two things is greater than or equal to 26, then we need to subtract 26 from it. Now why we need to subtract 26? Because if the addition of pen coding plus ken coding, if the addition of these two numbers, that is if the addition of 14 plus 12. So as you can see, 14 plus 12 is 26. So in our main parent table or in our alphabet table, we have number assigned till 25 only. So we have nothing at 26th number, and hence the result, what we are going to do, we are going to subtract 26 from any number which is equal to 26 or greater than 26. So if we have addition, that is pen coding addition is 14 plus pen coding number is 14 plus pen coding number is 12. Total is 26. So what we need to do, 26 subtract it with 26. So 26 minus 26, that is 0. And on 0th position, which alphabet we have? A. Then 13 plus 8, that is 21. So on 21 we have which alphabet? V. So this is our cipher text which is generating here. Then we have 0 plus 11. So 0 plus 11 is 11 only. And on 11 we have alphabet L. So we are going to write L in our cipher text. Then 15 plus 10, that is 25. So on 25 position we have Z. So I hope this particular point is clear. The same way we are going to add all pen coding numbers with can coding numbers. And if at any point of time our addition is greater than or equal to 26, then we need to subtract 26 from the same, and remaining number we are going to write here. So this is the pattern how we generate cipher text using Vigenère Cipher. First pattern of a wheel pattern, that was very basic, we are not using, that was not much popular. This is more popular, remember. So we have assumed some key. In our case, our key is milk. So the same key is present with sender as well as with receiver. Remember, sender and receiver both agrees on one particular key, and that key we are using in our message for encryption as well as for decryption. So here we basically got our encrypted message. Now what we are going to do, we are going to send this encrypted message to receiver. Now what receiver is going to do, receiver is going to decrypt this message, that is from non-readable text he is going to make it into or convert it into readable text. Using what? Using a common key. And what is our key? That is milk. So I hope the encryption part with respect to Vigenère Cipher is clear to each and every one of you. Now let's discuss how we are going to decrypt our message. So this is our cipher text. I hope you remember, we have in example 1 we have already done how to generate the cipher text or cipher code. So we have this cipher code written here. This is our parent table or a master table which we are going to use each and every point of time. This is most important. So cipher text and the numbers which are linked with alphabet which is present in our cipher text, those code or those numbers are called as cipher code. Then again what we are going to do, we are going to use a key. What is our key? Our key is milk. Now remember what we are going to do here, we are going to subtract cipher code with can coding number. So 0 minus 12. Now remember one thing, while adding or while creating a cipher text, what we have done there, whenever addition goes above 26, what we have done there, we have subtracted 26 from our number. The same way here, whenever our result or whenever subtraction result is in negative, what we are going to do, we are going to subtract the same number with 26. Suppose 0 minus 12, that is minus 12, as you can see here. So what we need to do, we are going to subtract 12 with 26. So 26 minus 12, that is 14. So our original alphabet or plain text alphabet is O. Then same way 21 minus 8. Remember, if the result or pen coding number which we are getting is in a negative, then we have to subtract 26 from it. And if subtraction result is positive number, then we are going to replace or we are going to find the same number from here only. So suppose 21 minus 8, that is 13. So here we are not going to subtract 26 from the same. So as you can see, 21 minus 8, our result is 13. So on 13th position we have N. So write N. Then 11 minus 11. So our result is 0. So on 0 we have A. Then 23 minus 12, 11, then 8 minus 8, 0, 24 minus 11, 13, 14 minus 10, 4, Same way 5 minus 12. Now 5 minus 12. So number is negative. Remember 5 minus 12. Number is negative. What is our number or what is our remaining number? So what we are going to do? We are going to minus or subtract 26 from the same as we did here. And the same way we are going to subtract or we are going to generate our basically our plain text. I hope this particular algorithm is clear. If you have any doubt or query, your comments are always welcome in comment section, or your queries are always welcome in comment section. Or if you have some doubt or query, you can feel free to ping me on this particular email ID, that is thiruv1488@gmail.com. And you can also follow me on this particular YouTube channel for more lectures. I hope whatever algorithm we discuss now is clear to each and every one of you. Some points are written here. Vigenère Cipher. The longer a keyword, the more difficult it will be for a third person to crack. So hence this algorithm is secure. In fact, for any plain text and any ciphertext of the same length, there is a key that connects to them. That is the same thing what we have discussed. Now example, as you can see, we have some plain text here, then we have some key here, and based by adding both this thing, that is pen coding plus can coding, we generate a ciphertext. That is what given here. Now let's discuss next algorithm, that is Beaufort Cipher. This type of a cipher, what we do here, now remember, it is also purely a type which we have discussed in Vigenère Cipher only. It is you can say all four type of algorithm under polyalphabetic are almost similar type only. We just need to remember here. So we have some plain text message. As you can see, what is our plain text message? How stuff works. This is our plain text message, and the same way we have assumed some key. Our key is cipher. What we are going to do? We need to assign numbers from A to Z as we did in a previous algorithm. So what we are going to do? We are going to assign 0 to A. Let me just show you. So this is how we are going to assign numbers. That is A, we have assigned some number, and same way from 0 till 25 we have assigned some number. Then pen coding and can coding, the same pattern goes here as well. So what we are going to do? We have written down our plain text, replace each and every alphabet which is present in your plain text with a number with reference to that table. Then we have some key, that is cipher, replace the key till our message ends, and then same way what we are going to do? We are going to write down, or we are going to find out the number which is there or which is present for each and every alphabet which is present in our key, that is called as can coding, pen coding, can coding. Here we got the cipher. I hope this particular point is clear. Now remember, it is not always same. Sorry for that. Basically I was just kidding. But when we talk about this type of algorithm, if you find this type of a plain text and key message, many a time people misunderstood it, that always we need to add only. But here what we are going to do? We are going to use this type of a table. Remember, we are going to write A to Z in a row pattern, that is horizontally and vertically. Then what we are going to do? We have in our message, we have H, that is how thing works. So first alphabet in our message is H. Now our key is C. As you can see here, our key is C. H and C. So we need to take a reference of this particular table, H and where C is linked here. So H and take here C, and where both this alphabet meets, at that junction or at that position we have which alphabet? J. So what we are going to do? We are going to replace H with J. Same way, how? H O. So at O we have ciphertext, that is I. So where O and I meets, we have a alphabet, that is W. So what we are going to do? We are going to replace O with W. Same way W, same way, same thing goes on. I hope this particular point is clear. Then we have next type of algorithm, that is one time pad. So what is one-time pad? Known as Vigenère Cipher only. Remember, many times they might ask you this type of a question in exam to just confuse you. So just remember, one-time pad, that is only once we are going to use any particular key during our communication. So once only we are going to use one key, that is one-time pad. Non-repeating characters in a key, that is the main motto behind this particular technique. So we are not going to use same and same key again and again. Rest all things are clear, similar to Vigenère Cipher. As you can see, pen coding plus ken coding. If addition goes greater than or equal to 26, subtract 26 from the same. So as you can see here, we have assigned numbers. Now here we have assigned numbers from 1 till 26. So for A we have assigned 1 and to Z we have assigned 26. Then we have some plain text here, that is how are you. Replace H with our some number which is present here with reference to our parent table. Same way ken coding. So we have assumed some key here. As you can see here, our key is not a word, it is a random character block or set of characters. So N, C, W, anything you can just assume. So what we are going to do, we are going to write down numbers here. Now one of the most important part, as you can see here, we have key and message. Both these things are of similar length. H, O, W, we have 9 letters present here and we have 9 letters present in our key as well. So our plain text and key size is same, and once only we are going to use this particular key. If next time I am again encrypting any particular message, then I am going to use some another key. Same key is not used twice. That is the main motto behind using one-time pad. So same thing, add these numbers. If addition goes above 26, subtract 26 from the same. And here we have generated ciphertext from the same. So I hope we have already discussed in Vigenère Cipher the same pattern. So how to decrypt it? Same Vigenère Cipher pattern only. What is the difference here? In Vigenère Cipher, we use very small key and we repeat the key till our plain text message ends. But here in this particular algorithm, what we are going to do, we are going to assume our key which is equal to our plain text message. So in our plain text message we have 10 alphabets, then our key should be 10 alphabets long. I hope this particular point is clear, and rest all technique is similar to Vigenère Cipher. Now the fourth type of algorithm is Playfair Cipher. Now what is this algorithm all about? Here we use a technique that is matrix pattern. What is matrix pattern? How it works? Let's just discuss directly with an example only. We have some message or plain text here. As you can see, our plain text messages. Crypto is too easy. This is our plain text message. You can use any different word or any different message. We have some key here, that is you can assume any other key. Now remember, we are talking about matrix. So what is matrix? Let's just see. As you can see here, we have this type of matrix present here. Now in this matrix, we need to write our key. Remember, we need to write our key. So our key is INFOSEC, and our matrix is of 5 by 5 matrix, 5 rows and 5 columns. I hope we have done in maths as well how to generate or how to write a matrix. So 5 into 5. How many total box we have? 5 5s are 25. So we have total 25 box present here. As you can see, 5 columns and 5 rows. This is our matrix, and this matrix we are going to use to encrypt our message. So how we are going to encrypt our message? We have to write this particular, remember we have to write this particular key first in our matrix. Now we have total 26 alphabets, but in our matrix we have 25 boxes only. 5 by 5 matrix means total 25 boxes. As you can count here as well, we have 25 boxes only. So for that reason, to accommodate all 26 alphabets, what we have done here, that we have kept I and J in one common box. That is, I and J are common, and for rest all other alphabets we have one box reserved here. So let's start writing our key in this particular matrix in same sequence on a row sequence only. So first either I'm going to write I or j, whatever is present there. So as you can see, I/j, then N, F, O, S, E, C. Now remember, if any time, at any point of time, if any alphabets repeats in your key, then we are not going to write the same alphabet twice. Remember, not going to write same alphabet twice. Each alphabet we are going to write once only. So as you can see, in our key we do not have any alphabet which is repeating. So we are going to write same key in a sequence manner, I, N, F, O, S, E, C. Now our key is not 25 character long, so it contains only 7 characters. So out of this 25 boxes, only 7 boxes, or you can say 6 boxes, are filled now. What we are going to do here now, we are going to write down other alphabets in an alphabetic order. For example, A, B, then C is already present in our key, so we are not going to write C. Instead of, we'll write D. Then E. E is also present in our message, so after E we have F. So F is also present in our message, so that is also not we are going to write. Then after F we have G, so G, H, then I we have in our message, I, J. I and J, we have common box only for I and J. I, J, K. Now K is not present in our message, in our key, sorry. So we are going to write K, L, M. Then N is also present in our key, so we are not going to write N. After N we have N, O. O is also present. Then after O we have O, P. So P, Q, R. Then S is present in our key, so we are not going to write S. Then we have T, U, V, W, X, Y, Z. So write down key first in this particular matrix. Then in alphabetic order we are going to write all the alphabet from A to Z. Only any alphabet which comes or which occurs in your key, skip those particular alphabets and write down rest all alphabets in an alphabetic order only from A to Z. I hope this particular pattern is clear. So if you are comfortable creating this type of a matrix, then you can easily generate your ciphertext. I hope this particular matrix is clear. So now let's see how to generate basically ciphertext from this. So here, as you can see, we have some plain text present here. Our plain text messages, crypto is too easy. Now what we need to do, we need to make a pair from this particular ciphertext. So CR, then YP, then TOIS, and remember, whenever if any alphabet repeating twice, then what we are going to do, we are going to write once that alphabet, and if we have O is repeating twice, then next time we are going to write O with X. Remember, we are going to write O with X. So XO, then EASY. So suppose if any alphabet, if we talk about ball, so L is repeating twice. So at that point of time, we are going to make a pair of L with any particular alphabet which is present in our plain text only, and next time we are going to write L with XL. So this is the main standard pattern. Now how we replaced or how we generated this particular ciphertext, let's see it. I'll just discuss here only. As you can see, we have CR present. So let's just see, here we have C and here we have R. As you can see, C and R are diagonal. Now, to replace this original alphabets with ciphertext, what we are going to do here, check exactly in opposite diagonal position which alphabet we have. So C and R. If we talk about exact opposite diagonal, we have A and Q. CR is replaced with AQ. As you can see here, we have replaced CR with AQ. Then we have YP. So where is Y? We have Y here and we have P here. As you can see, it is diagonal. So Y and P. Exact opposite of this, we have T and V. this diagonal and this diagonal. Or you can see we are going to replace Y with T and P with V. So this is our ciphertext. Same way TO. So here, where is T? Here we have T and here we have O. Now when we talk about this type of pattern, what we basically do is we need to check what is immediately. If both the alphabet in our pair comes in a same column, then we need to replace that alphabet with another alphabet which is immediately next to our original plain text message. So in T, what is immediately after that alphabet in our column? We have Y. So we are going to replace T with Y. And O, after O immediately comes B. So we are going to replace O with B. So as you can see, TO we have replaced with Y and B. Same way IS. Where is I? We have I here and S here. Now remember, S is the last character in our matrix. So if we are talking about a last character, so what is immediately after comes S? After S immediately comes I or J. So what we are going to do? We are going to apply the same pattern. So IS replaced with NI. As you can see here, same way TO, YB, EA, CB. I hope this particular pattern is clear. EA, E and A. So what we are going to do? We are going to replace E with C. Why? Because if alphabet comes in same row or same column, then we are going to replace that particular alphabet with immediately next alphabet which comes in that particular row or column. So EA. E and A both are in a same row. So after E immediately comes C. So we are going to replace E with C, and after A immediately next position comes at B. So we are going to replace A with B. So EA, CB. Then same way SY. Here we have S and here we have Y. So these are in a diagonal. So check exactly opposite characters in the same diagonal position. S and Y, exact opposite diagonal position, we have O and Z. So what we are going to do? Replace SY with OZ. You can apply another logic as well. So if we talk about if alphabets in a diagonal position, then what we are going to do? Just look what alphabet besides S, that is O, and what alphabet besides Y, that is Z. Don't get confused. You can just refer this diagonal logic only for this particular pattern. Now remember, we have too many algorithms present in network security. Here I try to make it as simple as possible for you. Now if you have any doubt or query, just feel free to ping me on my email ID, or you can just mention your comments in comment section as well. I hope this particular technique is clear. Next lecture will continue discussing Hill cipher. What is Hill cipher? This is our next lecture's algorithm or topic. I hope whatever we discussed till now is clear to you. If you want this particular notes, I have already provided a link for the same in video description section. And if you want to refer other lectures, as you can see, you will find link for the same in this particular video screen only. I hope everything is clear. In next lecture, we'll continue our Unit 1 discussion. Thank you.